Good morning to you all. Myself, MD Nazimul Haq. I would like to welcome you all to the presentation of the paper titled Feature Reduction through Data Preprocessing for Intrusion Detection in IoT Networks. The other authors are Tahania Tahmina Jui and Mohammad Soraf Hossain from Bangladesh University of Engineering and Technology, Bangladesh. Myself and Dr. Suryadipta Majumdar from Concordia University. At first, I would like to thank the anonymous reviewers for their comments. I would also like to express my gratitude to NSCRC for partially supporting these works. This is the agenda of today's presentation. At first, I would like to go to the motivations, then I will explain the contributions, and then I will show you the overview of the system, and then I will explain the results, and finally I will conclude with future direction. Nowadays, Internet of Things is the fastest growing mobile category devices after smartphone, and more organizations are using IoT devices for increasing their efficiency. This growing size of IoT devices and their applications creates a popular arena for a wide range of cyber attacks, including unwanted network intrusions. According to the statistics, the number of connected devices will be 75.44 billion by 2025. And the attackers are also improving their attacking knowledge. For example, this figure shows different kind of brute force attacks on different kind of uh, IoT devices. So a network intrusion detection systems is required to prevent different kind of intrusions in IoT devices. So there are different kind of intrusion detection system like signature based intrusion detection technique, anomaly based intrusion detection system, and among them anomaly based intrusion detection technique outperforms others. But due to the large volume of multidimensional data produced by IoT devices, it is difficult to deploy the anomaly-based intrusion detection system directly on IoT devices due to its resource constraint. So, IoT environment specifically requires a simple and time-efficient way of intrusion detection, along with maintaining high accuracy of the system. Most of the existing intrusion detection works are not focused to data processing and feature engineering, and most of the deep learning based work are mainly focused on accuracy rather than time efficiency of the systems. Moreover, lack of proper knowledge of its users in configuring the IoT systems, making it more challenging to implement an intrusion detection systems in IoT networks. So we investigate different combinations of data processing technique, feature selection technique, and classification algorithms to improve detection accuracy and reduce the detection time. Our main focus is reducing the detection time so that it can be deployed in the IoT networks or IoT environment directly. Through the experiments using one of the most recent IoT dataset called MQTT IoT IDS 2020, and one of the most popular benchmark dataset called NSLKDD, we find the best combination of data processing, feature selections, and classification algorithms, and show that the best combination of these algorithms can reduce the time while improve the accuracy. Our proposed approach is also more suitable in IoT environment where it requires a intrusion detection systems which can be applied in which requires low in resource consumption, time efficient, and applicable to heterogeneous data type. This is the overview of our whole systems. At first, we pre-process the data. To pre-process the data, we first import the data into Weka. Then we apply different pre-processing techniques. After applying the preprocessing technique, we apply different feature selection techniques, and when the feature reduced, on the reduced features we apply different classification algorithms, and measure the accuracy, and also measure the time efficiency, and based on the time efficiency and accuracy we find the best combination of the performance, and then we use the best combination of performance to predict or to detect anomaly or network intrusion. This figure shows the different combinations of data preprocessing, feature selection, and classification algorithms. We used three different data preprocessing techniques, which are normalization, oversampling, and undersampling. We also used different kind of feature selection techniques, which are based on two different search techniques called best first search and genetic search. We use three different supervised algorithm called naive Bayes, AdaBoost, and bagging for feature selections. We also use five different classification algorithms, which are naive Bayes, AdaBoost, bagging, decision tree, and random forest. We combined all of them and then measure the response time and accuracy, and we compare the response time and accuracy, then we find the best combination of performance. In our experimental center, first we would like to describe the dataset. We use two different datasets called NSL-KDD and MQTT IoT IDS 2020. Both the dataset deploy four different kind of attacks along with the normal data. So these are the attacks which are used in two different datasets. We used Weka for performing our experiments, which is an open source Java based software. We deploy our experiment in a laptop with Intel Core i7 CPU and 16 GB of physical memory. For testing we use 5-fold cross validation, and we used accuracy as the evaluation metric. We also measure the time efficiency. For measuring the time efficiency, we consider only the model training time. This is the experimental result. This shows the effect of feature reduction using preprocessing and feature selection algorithms. It shows that for NSL-KDD data, we are able to reduce the feature 40% to 93%. For example, using naive Bayes and based search as the feature selection algorithm on normalized data, we able to reduce we able to reduce 93% features, and we select only three features from out of 43 features. For MQTT IoT IDS 2020 datasets, we also able to reduce the features from 43.75% to 81.5%. This table shows the classification algorithm performance on the reduced dataset, and at first we apply different classification algorithm on NSL KDD dataset where the dataset is normalized, and in this table the row represent different kind of feature selection algorithms and the column represent different kind of classification algorithms. We find out that bagging is the classification algorithm and AdaBoost and genetic search as the feature selection algorithms on normalized KDD dataset perform the best. We found 84.21% accurate result in 0.79 second. For oversampling data, I mean for when we use oversampling as the data preprocessing technique on KDD dataset, we found that bagging and genetic search as the feature selection algorithm and bagging as classification algorithm perform best. When we use undersampling as the data preprocessing technique, we found that data boost and genetic search as the feature selection algorithm and bagging as the classification algorithms perform best. This is the summary of the performance of classification algorithm on NSLKD dataset. We found that for when we use normalization specificity technique, ADA boost, and genetic genetic search, we found best accuracy like 84.35%, while we use oversampling and normalization as the pre-processing technique, bagging and genetic search as the feature selection technique, and bagging is the classification technique. We we can also see that for NSLKD dataset, bagging as a classifier performs best, and genetic search also performs best for NSLKD dataset. This is the performance evaluation result on MQTT IoT IDS 2020 dataset. So finally, apply normalization as data preprocessing technique, and we found that ADA boost and best first search as the feature selection algorithm and decision tree as the classification algorithm give us the best result, which is 99.86% accuracy in 2.81 seconds. When you use oversampling as the oversampling as the data preprocessing technique on MQTT IoT IDS 2020 dataset, we found that ADA boost and best first search as feature selection algorithm on decision and decision tree as the classification algorithm give us the best result. When you use undersampling as the classification, undersampling as the data preprocessing technique, we found that naive Bayes and genetic search as the feature selection algorithm and decision tree as the classification algorithm provide the best result. This is the summary of the result, and we found that when we use normalization as the data preprocessing technique, ADA boost and best first search as the feature selection algorithm and decision tree as the classification algorithms, we found the best result, which is 99.86% accurate result in less than 2.81 second. So to conclude, we can say that for the MQTT IoT 2020 dataset, the combination of normalization as the preprocessing technique, ADA boost and best first search as the feature selection technique, and decision tree as the classification algorithm perform the best. And we found 99.86% accurate result in 2.81 seconds for MQTT IoT IDS 2020 dataset. We found that for NSL KDT dataset, the combination of oversampling as the preprocessing algorithm, bagging and genetic search as the feature selection technique, and bagging as the classification algorithm perform the best. We got less accuracy for NSL KDT dataset as our main focus was IoT data. So we think we can our approach minimize the time and classifying the time of classifying the anomalous data from normal data, which can be useful in an IoT environment. Thank you all. So if you have any question, please feel free to ask.